Hello children, welcome to channel Sube. Children, today I am going to discuss question number 5 from the MCQ part of 2021 Physics new syllabus paper. The mean kinetic energy of an ideal gas depends on its pressure, volume, density, absolute temperature, specific heat capacity. To answer this question, we have to revise the kinetic theory of gases. You must have learned it in physics and also in chemistry. So the relationship there we learn the kinetic energy of an ideal gas is proportional directly to the absolute temperature. So this relationship at least you must remember. Then easily you can select this answer is the correct one, because there is no any other temperature terms in other answers. So only this one they have given something about the temperature. So these others are entirely different. So therefore this question is easier according to that. Then since today we don't have much to do than this, so I am going to write the full equation and derive it. What is this equation? E kinetic energy equals 3 divided by 2 Boltzmann constant times capital T, that is the absolute temperature. So this K is Boltzmann constant and this T is the absolute temperature. Let us take it from here. So this one absolute temperature. So this equation we can use to if we happen to calculate the kinetic energy of an ideal gas. So what is this Boltzmann constant? This Boltzmann constant K is, we have to find it like this. We have to divide R by Avogadro number. Here R is the gas constant, universal gas constant. This one is the Avogadro's number. We have to substitute these values. If we happen to calculate, say in essay paper or sometimes in structure paper. So now you know what is Boltzmann constant. Just you have to divide universal gas constant R by the Avogadro number Na. So therefore we can write this equation like this even. Kinetic energy equals 3 divided by 2. Then instead of this K we can write R divided by Na times T, like this also you can write. Since these things are constant, all are constant, therefore that is why we take that kinetic energy is proportional to directly to the absolute temperature. So the value of Boltzmann constant is 1.38 times 10 power minus 23 joule per Kelvin. So let us try to calculate that value using this given data. Just what we have to do, divide this R by Na. Let us do it using this calculator. 8.31 we have to divide by 6.022. Here we get 1.379. 1.379. So the power, this one comes up as the numerator, so minus 223. So we get this value. This one is equal to this given value. So it is easier, it is not difficult, because sometimes they might in the exam give these values instead of Boltzmann constant. So at that time you have to get separately these values and divide and substitute in this equation. So that way you can do it easily. So that is why I showed you just by dividing those two values you can receive this Boltzmann constant. So children, what is this kinetic energy? So this kinetic energy, Avogadro said that this number is what? The number is what? The number of particles in a mole, the number of particles in a mole. So this one then, therefore, the kinetic energy of a particle. Therefore we can write like this. Then let us go to next step. So I explained all these symbols and how to calculate this Boltzmann constant if we happen to do it. So let us try to derive that equation. It is very simple because I am going to do this. Then you will understand something just keeping these equations in your mind. So therefore let us try to do this. So what is this question? What they ask is kinetic energy of an ideal gas. Kinetic energy, they ask kinetic energy. So we know kinetic energy. So this equation looks a little bit difficult and odd, but kinetic energy is a simple thing. We use that equation every day. So let us try kinetic energy. Kinetic energy, we know it is just half mv squared. Kinetic energy is half mv squared. So what we have to do now, find out the kinetic energy of a particle or of a molecule. Then let us find out the mass of a molecule. That is what we have to do. And the velocity of a molecule. That is what we have to do. Then if we substitute those things in this equation, we can get the kinetic energy of a particle or a molecule. So let us take a sample of gas. So there are gas particles like this. So let us suppose the mass, let us suppose first this gas is nitrogen. So then let us suppose the mass is 28 gram. Mass is simple M. Mass is 28 gram. Then what is the word that we can use for this sample? So this one is a mole. This one is a mole. So we can write therefore simple M equals capital M. So this capital M is molar mass. So then now what we are going to find is the mass of a particle, or mass of a molecule, because we need the kinetic energy of a particle. Then so I would like to write here first of all, otherwise. So let us try to find out this one, mass of a particle, because what we need is this one, kinetic energy of a particle. So we know now the total mass of this gas sample. So then since this sample is 1 mole, what Avogadro said, the number of particles are equal to this value. This value we write it using this symbol. So we don't have to go to the real values, therefore just let us use this symbols. So what is this number of particles? So now we can easily find out the mass of a particle. How? The total mass we know, capital M, The number of particles we know, so we have to divide capital M by Avogadro number. Then we get the mass of a single particle. So that is what we have to substitute here now. So let us do it now. Then equals half, instead of M we can write capital M divided by Avogadro's number, then V squared. So we are going to receive kinetic energy of a particle. So now that part is finished. Now what we have to do, we have to find out this velocity or the speed, speed of a particle. Gas particle, speed of particle. So now what is the equation that gives us the speed of a particle? So you must remember the speed of particle equals root 3 times RT divided by capital M. So this V is the speed of a particle, gas particle. So let us therefore write like this. What we want is here in this equation, the velocity you can find using this equation. But normally you don't write this equation like this. Normally we write this equation c squared bar root like this. Root mean squared. We say root mean square speed, root mean square speed equals 3 times RT divided by capital M. This is how we normally say. So this is how we say, we identify this term root mean squared speed of the of gas molecules. Root mean squared speed of a gas molecule. So that is just the speed, that is just the speed of a particle. But if I write this thing, if I use this thing, you get squared. Therefore I don't use it, just keep it aside. Let us so take this term as the just speed of a particle, because we want to put it here, substitute here that value. So first of all we have to get the square value from this. So V squared is just without the root 3 times RT divided by M. So let us write it here. So we are following this half mv squared equation. Don't be scared, it is very simple beginning. So half m divided by Na, v squared is 3 times RT divided by capital M. So this value, this term we substitute here, v squared part we substitute here. So E kinetic, then we see that there are 2 capital M's, cancel, then 3 is there at the numerator, RT, then 2 is there, Na, that's all. So we can just rearrange a little bit. Kinetic energy equals 3 by 2 separately R divided by Na, because there is going to be Boltzmann constant alone, times T. So finally we can write E kinetic energy of a molecule, not a mole, of a molecule or of a particle, 3 divided by 2, then this term is known as Boltzmann constant, then times T. So this is the final equation. So it is not difficult, you see. You have to use this equation. The speed is given by this term, by this equation. So just the speed of a gas particle or air particle. Then we substitute it to half times m times v squared equation, just our kinetic energy equation. So we found the mass of a particle using Avogadro number, and the mass of a mole, capital M. Using that we found this simple M. Substitute this term to simple M and substitute this term to velocity. That is what we did. Just two steps. Then we derived this equation. So if you remember this equation, if you remember the path to approach this equation, then it will be very useful in your essay examination. If you are lucky, you will get a question in this part. So children, today I have to finish wind up this question, because as usually we can't explain these other answers, because we must use this complicated equation to explain this relationship with this kinetic energy of an ideal gas and the absolute temperature. In a simple manner, we can't just talk pressure affect this thing, pressure influence like this, and volume influence like this, and density influence like this, because we can't do like that, because this is a very complicated phenomenon. So using this equation only we can do it. So therefore we can't do it as usual, so we have to wind up today now. So children, thank you very much. I think you might be happy, I don't know. Just you have to choose this answer if you remember this relationship. So I did something more than that. So children, if you are happy, please subscribe my channel, then I will be happy. So see you tomorrow. Goodbye.